Hey guys, hope all is well. So we're starting our next unit. We just finished Unit 7, which was Exponent, Scientific Notation, and Volume, and now we're starting Unit 8. So obviously we don't have a workbook to give you, so you'll always have to look at the sheets on your computer. You can print them out if you have a printer and are able to do that. Otherwise, you can take the notes on your own paper. I suggest you keep yourselves really organized. So take that last unit, put it in a folder, put it to the side, and now let's start a new folder or a new binder with this new unit, which is called functions. So lesson 1, the objective is that we're going to learn what the definition of a function is, and we'll be able to represent functions in a few different ways. We can represent them as ordered pairs, which are like points, or we can see our points in a table of values, as what we call a mapping, and then also graphically. And you have a do now to do on page 1. So it would be great if you could pause and try and do that on your own. And then when I go over it with you, make sure you have the right answers. I am going to go over the do now, and I am going to do the development with you. By the end of this lesson, you should be able to tell me what a function is. And then your homework is the problem set, which is page 4. So this is your problem set. This is page 4. So the lesson starts with this vending machine. And suppose you inserted your money and pressed A1, what item would you receive? So if I pressed A1, I would definitely get Gone with the Breeze. Suppose you inserted your money and pressed C2. If I press C2, I'm going to get Raiders of the Mossed Bark. And suppose you inserted your money and pressed B3, what item would you receive? I would get the Wizard of Gauze. If the machine were filled properly, what would happen if you pressed any of those same buttons again? Well, if it was filled properly, we would expect the same thing to happen. So believe it or not, if you understand how a correctly working vending machine works, then you actually understand how a function works. With a function, there is an input. In this case, it would be pressing the button. And when you do the input, then you have an output. And the output with the vending machine is actually dispensing what the video is. So each time you press a button, which is your input, you receive a DVD, which is your output. In the DVD vending machine situation, does every input have an output? So every single time I push a button, do I get something out? The answer is yes, as long as the machine is properly working. So we're assuming that we have a properly working machine. So every time I push a button, I expect to get a DVD. So does every input have an output? Yes. Every time I push a button, a DVD will come out. So each combination of input and output can be expressed as a mapping. When we do it as a mapping, we draw an arrow from the input to the output. So for example, B2 has an arrow that gets drawn to the Wizard of Gauze. So write each of the possible combinations of buttons pushed and DVDs received as a mapping. So I'm going to list all of my inputs in a column. My inputs are A1, A2, A3, B1, B2, B3, and C1, C2, C3. So we like all of our inputs in one area. So A1, A2, A3, B1, B2, B3, and C1, C2, and C3. I actually wish I had more room. I'm going to move this up a tiny bit. So there's my inputs. Sometimes people even like put this in like a circle and call them the inputs. Now each input has to have an arrow coming out of it pointing to its output. So A1 goes to Gone with the Breeze. A2, The Godmother. A3, Star Battles. B1, Wizard of Gauze. B2 is also the Wizard of Gauze, and B3 is the Wizard of Gauze. So I can write the Wizard of Gauze and all of the arrows point to the same place. So notice each input has an arrow coming out of it. Just so happens that all three of these arrows are pointing to the same place. C1 goes to Finding Dreamo. C2 and C3 both go to Raiders of the Lost Ark. So we said both C2 and C3. And we can put all of the outputs in a circle also and call them the outputs. And this is a mapping because it is using arrows to show which input belongs to which output. So this is writing all the possible combinations as a mapping. So mappings relate functions from one set of numbers to another, and those mappings can then be written as ordered pairs. So an ordered pair, remember, is a point written in parentheses. So we're going to look at this mapping down here that uses numbers. So the input of 1 goes to the output of -2, therefore we write it as the point 1 comma -2. So the next one would be 2, 1. This would be 3, 4, and this would be 4, 7. So the input always comes first. The input is your X value. The output comes second, which is your Y value. Above the input column, we could actually put an X, and above the output column, we could put a Y. So inputs and outputs can look like tables of values. Inputs and outputs can be rewritten as ordered pairs, and inputs and outputs can be written as a mapping with these arrows. So all of these things are called relations, right? When you compare like one set of items to another, they're all relations. Not every relation is a function though. So we are going to be talking about what makes a relation a function. Again, this is showing all different ways that we can write um, our relations. So as a table or as ordered pairs, remember this would be 1, 4, 2, 3, and 6, 5. These same points are written as a mapping here, and these same points are then plotted. Here's the point 1, 4, here's the point 2, 3, and here's the point 6, 5. So those are the different ways that we can show our relations, and some relations are functions. A function is a relation where every input has one and only one output. So if we compare and contrast the DVD vending machine with a function, did every input have one output? The answer was yes. So the correctly working vending machine represents a function. Notice I said correctly working vending machines. You know those vending machines at school even. Have you ever been, what I guess you probably consider yourself lucky, you put in money, you push the button, and 2 items come out? Right? So that's not a correctly working vending machine. Something went wrong there. If you push the button once and 2 things come out, that's actually not a function. A function says that every input has one and only one output. So this sentence up here is so important. Every input has one and only one output. So incorrectly working vending machines are not functions. Also, have you ever been very unlucky with your vending machine? You put in the money, you push the button in, nothing comes out. Okay, that's not a function either because you push the button, you expect something to come out. So every input should have one and only one output. You can't have multiple things coming out. You can't have nothing coming out. One and only one output. So suppose when pressing button C1 in our vending machine in our Do Now, suppose both Finding Dreamo and Raiders of the Moss Bar come out. How does this broken vending machine resemble or not resemble? It's not a function because one input can't have 2 outputs. Okay, so just remember that. We're always looking for every input only having one output. So number 3, imagine a machine where you input an age, and the machine gives you the name of anyone who is that age. Compare and contrast this machine with a function. So if I input the age of 13, how many names are going to come out? Oh my gosh, tons of names, right? Joe will come out. Sue will come out, Brody will come out, etc. Lots more will come out. So the age of 13, if I do it as a mapping, that's what I'm trying to show you here. I'm trying to show it to you as a mapping. Multiple arrows are coming out of one input. If you have more than one arrow coming out of an input, it's not a function, because the input of 13 has more than one output. Okay, so it says explain by using examples. Here's my example uh, as a mapping, showing that if you have more than one arrow coming out, it's not a function because the input of 13 has more than one output. So identify whether each list of ordered pairs represents a function. Some people get confused by looking at it as ordered pairs. Like you take a look at number 4, and right now in your mind, think about whether you think it's a function or not. So Yes, it's a function. I like to prove it using a mapping though. I list my inputs. The inputs, remember, are the x values. So I list my inputs, 5, 6, and 7. And then I list my outputs, 4, 3, and 2. And I draw an arrow from each input to the output. 5 goes to 4, 6 goes to 3, 7 goes to 2. Each input only has one arrow coming out of it, so this is a function. Look at number 5. You think about whether you think it's a function or not. So yes, this one's not a function. Look at the inputs. When I list my inputs, I'm not going to list 4, 4, and 5. The number 4 is definitely input. I see it twice. And the number 5 is definitely an input. So when you list your inputs, if a number is going to be repeating more than once, please only write it one time. As long as you say, oh, 4 is an input and 5 is an input, I just listed all the different inputs. So this is listing the different possibilities for our inputs. And then I can list the different possibilities for the outputs. I see a 5, 3, and a 2. Oh yeah, 5, 3, and 2. 4 goes to 5. 4 goes to 3. And 5 goes to 2. Right here is the problem. Do you see there's 2 arrows coming out of the 4? This is not a function. And the best reason to write down is by being a bit specific. It's not a function because the input of 4 has more than one output. And then finally, number 6, you decide if you think it's a function or not by the look of it. And let's prove that it is a function by using a mapping. Some people get tricked on this one. Look at the inputs. List all different inputs. I'm going to list 5, 6, and 7. Look at the outputs. List all the different outputs that there are. So the only thing I list is 4. 5 goes to 4. 6 goes to 4. And 7 goes to 4. Remember, the thing that determines if something's a function is if each input has one output. Does each of these inputs only have one arrow coming out of it? Yeah, they do, right? Each input only has one arrow. I don't care where the arrow points to. If each input only has one arrow coming out of it, it is a function. I'm going to say each input has only one output, has one and only one output. So using positive integers, write two relations as a list of ordered pairs, one that is a function and one that's not. So to be a function, every input can only have one output. So I could say 1 goes to 2, 2 goes to 3, and 3 goes to 4. I mean, there's an infinite amount of things I can make that is a function. And I'm going to make this not a function. I'm going to pick the input of 4, going to a few things. set of all inputs for a function is known as the domain of the function, and a set of all outputs of a function is known as the range. So domain and range are fancy words that mean input and output. So I could say that the domain really is your input, which really is your x values. The range really is your output, which really is your y values. So in place of input, I can write domain, or I can write x's. For output, I could call it the range, or I could call it the y's. When it asks us to identify it, they want us to write out something like this. They want us to say that the domain, in this case, consists of, I'm going to put it in numerical order, the numbers 3, 5, and 7. And it's a set of numbers, so it goes in squiggly brackets. The range consists of the numbers 6, -2, and 1. Again, I'm going to put it in numerical order, so I'll write -2, 1, and 6. That's what they're looking for in these problems. So for part B, the domain, I'm going to use just a D for domain, consists of the numbers 2, 6, and 8. I'm going to use R for range. And the range consists of the numbers 4 and -3. I'm just going to put it in numerical order. And C, I'm going to label these points actually so I could see the x, y values. This is a 2, 4. This point is 3, 1. And this point is 5, 3. So the domain are the x values. The different x values are 2, 3, and 5. The range are the different y values. 4, 1, and 3. I'll do numerical order. And in letter D, the domain are the x values, -7, 9, and -6. -7, -6, and 9. I just like going in numerical order. And the range, I see a 0, a -3, and a 2.5. So I'll write -3, 0, 2.5. And there we go. So I said by the end of this, you should be able to tell me if something's a function or not. Remember, in order to be a function, every input can only have one output. And I'm a visual learner, so it's easiest for me to see this by looking at a mapping. Other people maybe see it better other ways. Everyone has their own way of learning and understanding things. But since I'm the one doing this video, I like to talk about the mapping because it just stands out to me. You only have one page for homework. It shouldn't really take that long. And then the answers will be posted the following day. So enjoy the rest of your day. Remember to send us, Mrs. Lawton, or me any questions that you might have. And we will talk to you soon. See ya. Bye.